In this lesson, I'm going to go over some basic concepts in geometry that you want to be familiar with. So the first thing we're going to talk about is a line. What is a line? Now, many of you may think of a line as just something that looks like that. But in geometry, a line would have two arrows. And so it extends in opposite directions forever. Now, let's put some points on this line. So we can call this line line AB. We could also call it line BC. And we could also call it line AC. So there's many ways in which we can name this particular line. Now, what about a ray? How would you describe a ray? A ray has a point and it extends forever in the other direction. So it has a point and an arrow. So let's put some other points on this ray. Let's call this A, B, C. So we can name this ray AC, or we can name it ray, not BC, but AC. I mean AB. The reason why we can't name it ray BC is because the first point has to start at the initial point or the starting point of the ray. So we need to use point A as our starting point. Now the next one you need to be familiar with is something called a segment. A segment has a beginning and it has an end. So let's say this is point A and point B. So we can describe it as segment AB with no arrows on it, or we could say this is segment BA. So that's a segment. Now let's move on to angles. There's 4 different angles that you need to be familiar with. So the first one is an acute angle. Acute angles have an angle measure of anywhere between 0 and 90, but it's less than 90. That's what you want to take from this. And so we can call this angle ABC. And if you notice, an angle is formed by the union of two rays. So here we have ray BA and ray BC. And so this forms at the vertex, creating an angle. The next angle is the right angle. And a right angle has an angle measure of 90 degrees. The next one you need to be familiar with is something called an obtuse angle. So the obtuse angle has an angle that's greater than 90 but less than 180. And finally, you need to be familiar with the straight angle. The straight angle has a measure of 180 degrees. So that's a straight angle. It looks basically like a line. Now let's move on to the midpoint. What is a midpoint? Well, if you look at the word, it sounds like the point in the middle. And you wouldn't be incorrect by saying that. So let's say if we have a segment, we'll call it segment AC. And let's say B is the midpoint. So what does that mean? That means that B is right in the middle of segment AC. It also means that segment AB and BC are congruent. So if you put these marks, it shows that this segment is equal to that segment. And the way you would write that is as follows. So you would say segment AB is congruent to segment BC. And so if that's true, that means that B is the midpoint of segment AC. Thus, B bisects segment AC into 2 equal parts. Now, another term you need to be familiar with is something called, what just happened here? Something called a segment bisector. So let's say if we have a ray that passes through the midpoint. And let's say this is R. So ray RB is considered a segment bisector because it bisects the segment into two congruent parts. So we can see that AB and BC are congruent to each other. Next up in our list of things to discuss is the angle bisector. So what is an angle bisector? An angle bisector is a ray that bisects an angle into two equal parts. So let's say we have, let's call this angle ABC, and we have a ray that emanates from point B, and let's call this ray BD. So ray BD is an angle bisector if it bisects angle ABC into two equal parts. So let's say that angle ABC is 60 degrees. By the way, when you name an angle, the vertex of the angle has to be in the middle. So you can call it angle ABC, or you can call it angle CBA. So B has to be in the middle. So if ray BD is an angle bisector, that means that angle ABD has to be 30 and angle DBC has to be 30. Now let's move on to parallel lines. So what do you know about parallel lines? What are some properties of parallel lines? Parallel lines never intersect. So let's call this line A and line B. Parallel lines also have the same slope. So let's say the slope of line A is a half. The slope of line B will also be a half. And the way you can describe that these two lines are parallel, the geometry symbol for it looks like this. So you say A is parallel to B. So you would use two lines to indicate that A is parallel to B. Now let's talk about perpendicular lines. What are perpendicular lines? And how are they different from parallel lines? As we said before, parallel lines do not intersect each other, but perpendicular lines, they do intersect each other. In fact, they do so at right angles. So let's call this line A and line B. So they're going to meet at a 90-degree angle. Now, let's say that the slope of line B is positive 2/5. What is the slope of line A, given that it's perpendicular to line B? To find the slope of a perpendicular line, first, you need to flip the fraction and change the sign from positive to negative. So the slopes are negative reciprocals of each other. And the symbol for it goes as follows. So we could say line A is perpendicular to line B. So that's the geometric symbol that correlates to perpendicular lines. The next term that you need to know in geometry is complementary angles. So what are complementary angles? Complementary angles are angles that add up to 90 degrees. So let's say if we have a right triangle, and let's call this triangle ABC. So the symbol for that is as follows. So this is triangle ABC. And let's say that angle A is 40 degrees and angle C has a measure of 50 degrees. In this case, we could say that angle A and angle C are complementary because their angle measures add up to 90 degrees. And so that's the basic idea behind complementary angles. So the measure of angle A plus the measure of angle C is equal to 90. Next, we have supplementary angles. Now, based on the last topic, you can probably guess what this is about. Supplementary angles are angles that add up to 180. Now, if you remember, a straight angle has an angle measure of 180, so we need to be dealing with a line. So let's put some points. Let's say this is point A, B, C, and D. Let's say angle ABD has a measure of 110, and angle DBC has what measure? What would you say it should be? Now remember, a straight angle is 180, so 110 plus what number is 180? This has to be 70. So because the measure of angle ABD and the measure of angle, let's call this CBD, or you could say DBC, because they add up to 180, we could say that those two angles are supplementary angles. The next geometric term that you need to be familiar with is something called the transitive property. So what is the transitive property? The definition is as follows. If two angles are congruent to the same angle, then they are congruent to each other. Okay, so what does that mean? Let's say if angle 1 is congruent to angle 2, and if angle 3 is congruent to angle 2, then we can come up with this conclusion. We could say that angle 1 is congruent to angle 3. Now it seems obvious, but you need to know that this property it matches this situation. Because if you're doing, let's say, a problem with two-column proofs, you need to know that the transitive property corresponds to this particular situation. Now, another way in which you could describe the transitive property is using variables. So you can say that if A is equal to B and if C is equal to B, then that means that A has to equal C. So we can write then A is equal to C. And that's the basic idea behind the transitive property. So that's something else that you want to add to your notes. Next, you need to be familiar with vertical angles if you're working on two-column proofs and problems similar to that. So what are vertical angles? Well, we can form vertical angles by drawing two lines that intersect each other. Let's call this angle 1, 2, 3, and 4. So the opposite angles are congruent. Angle 1 is congruent to angle 3. So thus you can describe them as vertical angles. Angle 2 and angle 4, they're also vertical angles. They are congruent to each other. So let me give you an example problem. Let's say if this angle is 50. What are the other three angles? This angle has to be 50 because they're vertical angles. Now, these two angles, let's call this angle X and 50, they form a linear pair. So therefore, they have to add up to 180. 180 minus 50 is 130. So the angle opposite to 130 is a vertical angle to it. So this must also be 130. And so that's how you can use vertical angles to find missing angles in a typical geometry course. Now, for those of you who haven't done so already, feel free to subscribe to this channel and check out the description section of this video when you get a chance. I'm going to post some links to it. Because in this video, I don't have many practice problems. And for those of you who want it, I'm going to have another video with plenty of practice problems. I'm also going to include my geometry video playlists for those of you who need help on specific topics in geometry. So when you get a chance, check out the description section of this video and don't forget to subscribe. And if you decide to do that, make sure to click on that notification bell so you can receive new videos that I'm going to post in the future. Now let's talk about medians. What is a median? To understand this concept, let's begin by drawing a triangle. And so let's call this triangle ABC. And we're going to draw a line segment from B to some point which we'll call D. Now in this example, segment BD is a median. A median is a line segment drawn from the vertex of a triangle to the midpoint on the other side of the triangle. So that means that D is the midpoint. So if D is the midpoint of segment AC, that means AD and DC are congruent to each other. And so that's what a median does. A median is just a line segment. It touches the midpoint of the other side, and it splits one side of the triangle into two equal parts. Now let's talk about altitudes. What is an altitude and how does it relate to a median? So let's use another triangle as our example. And we're going to call it triangle ABC again with point D. So this time, BD is going to represent an altitude. So like a median, an altitude is a line segment. But the difference is D is not a midpoint. The altitude forms right triangles with, in this case, segment AC. So angle ADB, which is congruent to angle CDB, both angles are equal to 90 degrees. So the altitude forms right angles inside the triangle, and that's what you need to know. Now we can also say that segment BD is perpendicular to segment AC, because perpendicular lines and perpendicular segments, they intersect at right angles. So if you have an altitude, you can also make this statement. Now the next thing we're going to talk about is a perpendicular bisector. So looking at the words perpendicular and bisector, what do you think this represents? So let's say if we have a line segment, which we'll call segment AB, and we're going to draw a line that's perpendicular to it. And let's call this line L. So line L is perpendicular to segment AB, which means that it's going to form a right angle with segment AB. Now it's also a bisector. So if we draw another point, we'll call it point M. M is the midpoint of segment AB. So a perpendicular bisector forms right angles with the segment that it intersects, and at the same time, it also bisects the segment into two congruent parts. So when dealing with perpendicular bisectors, you can say things like segment AM is congruent to segment BM. You can also say that M is a midpoint. And you could also say that angle, let's add some points here. So let's call this point P and point Q. So we could say that angle AMP and angle BMP, these are right angles. So perpendicular bisectors, they are lines that bisect a segment into two equal parts, and they form right angles with that segment. Personally, I like to think of perpendicular bisectors as a hybrid of a median and an altitude. So like a median, it touches the segment at the midpoint and it bisects it into two equal parts. And like an altitude, it forms right angles. So it has features of both. Now there's something else that you need to know about perpendicular bisectors. And let's focus on point P. So notice that AM and BM, they're congruent to each other. And these two triangles, they share a common side, side PM. Therefore, because these two sides are the same and this side is a common side, which is associated with the reflexive property, it turns out that AP is congruent to BP. And so that's another feature of perpendicular bisectors, is that any point on the perpendicular bisector is equidistant to the endpoints of the segment that it bisects. So P is equidistant to points A and B. So we can say that AP is congruent to BP. And we could also say the same of point Q. So AQ and BQ, they're congruent to each other. So those are some things that you want to keep in mind when dealing with perpendicular bisectors. A common problem that you're going to encounter in geometry is proving that two triangles are congruent. And so let's say if these are the two triangles we're dealing with. We have triangle ABC and triangle DEF. Now there's 4 postulates that you need to be familiar with. There's some other ones too, but we're going to cover 4 of them. So let's say that AB and DE are congruent to each other, and BC is congruent to EF, and AC is congruent to DF. Then we could say that triangle ABC is congruent to triangle DEF according to the SSS postulate, because all 3 sides are congruent to each other. And so that's the first postulate you need to be familiar with. Now when you write this expression, you need to write it in such a way that the letters of each triangle correspond to each other. So angle A corresponds to angle D because they're opposite to congruent sides. Likewise, angle B corresponds to angle E. They're opposite to congruent sides, and so we need to make sure that they match when writing this statement. And angle C corresponds to angle F. Now let's look at another example, but let's use different letters. So let's call this triangle XYZ, and let's call this triangle RST. And let's say that segment XY is congruent to RS, and segment XZ is congruent to RT, and angle X is congruent to angle R. What postulate can we use to prove that these two triangles are congruent? So we have a side, an angle, and a side. So we could use the SAS postulate to make the statement that triangle XYZ is congruent to triangle RST. And so that's the second postulate that you need to be familiar with in order to prove that two triangles are congruent. Now, once you prove that two triangles are congruent, you can also make another statement. For instance, now that we know that these two triangles are congruent, I can say that angle Y is congruent to angle S. And the reason why I can say that is something called CPCTC. Corresponding parts of congruent triangles are congruent. So once you prove that two triangles are congruent, then you can make a statement that other portions of that triangle are congruent as well, using this as your reason. Now let's try another example. So let's call this triangle MNO, and this one we're going to call it GHI. And let's say that angle N is congruent to angle H, segment MN is congruent to segment GH, and angle M is congruent to angle G. So what postulate can we use to prove that these two triangles are congruent? So we have an angle, a side, and an angle. So we could use the ASA postulate, angle, side, angle, to say that triangle MNO is congruent to triangle GHI. So now that we've proven that the two triangles are congruent, I can make a statement and say that another portion of these triangles are congruent. I could say that MO is congruent to segment GI. And the reason is CPCTC. Corresponding parts of congruent triangles are congruent. Now there's one more postulate that I want to go over. So let's say this is triangle ABC, and this is triangle RST. Let's say that angle A is congruent to angle R, angle C is congruent to angle T, and let's say that BC is congruent to ST. So what postulate can we use to prove that these two triangles are congruent? So here we have an angle, and a side. So we could use the AAS postulate to make the statement that triangle ABC is congruent to triangle RST. And so that's the fourth postulate you want to know. There's another one called the hypotenuse leg postulate, which I'm not going to post in this video, but you could find it if you check out my new geometry video playlist, or if you type in HGel postulate organic chemistry tutor in your YouTube search box, it should come up. Now let's work on some problems. So let's say that this is ADC, and we're going to have a composite triangle. So let's say that we're given that segment AD is congruent to segment DC, and segment AB is congruent to segment BC. How can we prove that these two triangles are congruent? That is triangle ABD and CBD. What can we do? Right now, we see that two sides are congruent. But notice that both triangles share a congruent side. If we were to split this triangle into two parts, such that we have triangle ABD and triangle CBD. So we can see that AD and DC are congruent because that's given to us. AB is congruent to BC. And also, DB is congruent to itself based on the reflexive property. So thus we could say that triangle ABD is congruent to triangle CBD according to the SSS postulate. Now, using CPCTC, we can make a statement that, let's say, angle A is congruent to angle C based on CPCTC. Here is another example. So let's say this is A, B, C, D, and E. And let's say we're given that angle A is congruent to angle E, and AC is congruent to CE. Prove that angles B and D are congruent. Now you could set this up as a two-column proof, but I'm not going to do that here. I'm just going to discuss it, the process of proving that these two triangles are congruent. But if you want actual two-column proof problems, check out the links in the description of this video. I'm going to post some videos where you can find more practice on this topic. This video is just a quick review of topics that you need to know in geometry. So right now, we can't use any postulates here because all we have is an angle and a side. We don't have this yet. This is what we're trying to prove. So we can't use that right now. So what else do we know about triangles ACB and ECD. Notice that angles ACB and ECB are congruent to each other because they form vertical angles. Vertical angles are congruent. So based on the ASA, angle side angle postulate, we can make the statement that triangle ACB is congruent to triangle ECD. Now, once we prove that the two triangles are congruent, now we can make the statement that angle B is congruent to angle D using CPCTC. And we don't have to stop there. If we want to, we can show that segment AB is congruent to segment ED, also using CPCTC as a reason. Now let's consider one more example. So let's say this is triangle ABC, and let's say that we're given that BD is an altitude. In addition, let's say we're given that angle A is congruent to angle C. So let me just write given. Your task is to verbally prove that angle ABD is congruent to angle CBD. So feel free to pause the video and come up with a process that will prove that this statement is true. So first, let's mark down what we know. Angle A is congruent to angle C. And so that's given. Now, BD is an altitude. What do we know about altitudes? Altitudes, they form right angles. So angle ADB is congruent to angle CDB. Now, in addition, triangle ADB share a same side with triangle CBD. So if we split it into two triangles, triangle ADB and CDB, we could say that these two sides are congruent based on the reflexive property, and we have that angle D is congruent to each other and angle A is congruent. So thus we have angle, angle, side. And so we could prove that the two triangles are congruent. So we can make the statement that triangle ADB is congruent to triangle CDB. Now that we've proven that the two triangles are congruent, we can make the statement that angle ABD is congruent to angle CBD. According to CPCTC, corresponding parts of congruent triangles are congruent. And so that would complete this problem, but you could set it up as a two-column proof if you want to. And using CPCTC, we can also say that segment AB is congruent to segment BC, or we could say that segment AD is congruent to segment CD. And so using CPCTC, you can also prove that any other parts of the two triangles are congruent. So that's my 2 cents for today. That's all I got. And before you leave, don't forget to subscribe to this channel and check out the links in the description for those of you who want more practice problems. Thanks again for watching.